Multiple reports this week suggest that Elon Musk has greenlit production plans for the 2026 Tesla Pi phone, expected to debut at under $157. Internal supply chain documents from Shanghai and early Starlink integration tests appear to back it up, fueling claims that Tesla's first smartphone will connect directly to Starlink satellites, bypassing traditional carriers altogether. But is Tesla really building a sub-$200 smartphone powerful enough to challenge iPhone 17? How would it integrate with Starlink, Tesla cars, or even Neuralink in daily life? And if this rumor turns out to be real, what happens to Apple's ecosystem dominance? That's exactly what we'll break down today. This is AutoGearshift, where we cover Tesla's moves with hard facts, engineering logic, and zero fluff. If you want analysis that cuts deeper than the headlines, hit subscribe and turn on the bell to help us reach 12,579 subscribers. The next milestone that puts you inside the first circle of real Tesla insiders. Let's dive in. Where did the Pi phone rumor actually begin, and is there real evidence behind it? The origins of the Tesla Pi phone rumor stretch back to November 2022, when Elon Musk made a seemingly offhand remark that would later become a cornerstone of speculation. Amid tensions with Apple over potential App Store restrictions on X, formerly Twitter, Musk publicly posted, "If that happens, I'll make an alternative phone." At that time, most saw it as a defiant joke, until Tesla's 2025 Q2 earnings call reignited the theory. During the call, Musk told investors, "We're developing devices that integrate directly with Starlink." That single line marked the first official hint that Tesla might be venturing into handheld technology, and it immediately triggered a surge of over 420,000 online mentions of the term Tesla phone within just 3 days, according to Social Blade trend data. By mid-2025, the rumor evolved into something far more tangible. Supply chain trackers in Shanghai's Lingang district reported the appearance of a mysterious codename, TP26, in logistics and testing documents. Analysts quickly decoded it as Tesla Phone 2026. Leaked component manifests showed BOE contracted to supply 6.1-inch OLED panels, featuring a 120 Hz adaptive refresh rate and HDR10+ certification, while KATL, Tesla's longtime battery partner, was allegedly developing a 4,800 mAh aluminum-ion cell prototype specifically labeled for mobile integration. Even more telling, insider production data pointed to a pilot manufacturing line scheduled for the third quarter of 2026, suggesting Tesla's Gigafactory Shanghai would handle early test batches capable of producing 50,000 units per quarter. Be honest, if the Tesla Pi phone really launches for under $157, would you actually buy it? Comment yes if you'd switch from your current phone to try it. Comment no if you'd still stick with your iPhone or Android. Tell us why in the comments. We're curious which side you're on. And if you're into this kind of story, search Pi phone on our channel to check out the other videos we've made diving even deeper into Tesla's rumored smartphone revolution. How could Tesla really sell the Pi phone for just $157? A Tesla-made smartphone priced at $157 sounds absurd, especially when the iPhone 17 starts at $899. But recent leaks and cost model projections suggest that this number isn't fantasy. It's basic Tesla economics. The key lies in how Musk's ecosystem erases traditional markups across hardware, energy, and distribution, a strategy Apple can't replicate. According to reports from Tesla's 2025 supplier documentation, the company's new Dojo Lite AI chip, a 5-nanometer SoC built in collaboration with TSMC, costs about $42 per unit, versus roughly $68 for Apple's A17 Pro. By producing its own chip using existing Dojo architecture, Tesla cuts processing costs by 38% and avoids licensing or design fees entirely. Then comes the aluminum-ion battery, arguably the single biggest disruptor. Industry insiders from CATL's R&D division claim Tesla's battery production cost could drop to $35 per kilowatt-hour, compared to $101 per kilowatt-hour for lithium-ion packs used in flagship smartphones. That's a 65% reduction in energy cost for a cell that delivers 1.7 times higher energy density and charges 3 times faster. A smartphone battery typically stores around 15 watt-hours of energy. This chemistry would cut battery material expenses from about $6.50 to under $2.30 per phone. On the factory floor, the savings grow even deeper. Data from Tesla Shanghai Gigafactory indicates that with Optimus humanoid robots taking over 60% of repetitive assembly tasks, labor hours per device could drop from 3.2 hours, industry average, to just 2.1 hours, translating to approximately 30% lower workforce costs. That alone could shave another $12 to $14 per unit once scaled. But perhaps the most aggressive cost cut is in distribution. By selling directly via Tesla stores, online pre-orders, and even integration with X, Twitter commerce, the company would eliminate the 12 to 15% commission typically paid to carrier networks and retailers. On a $157 product, that's $18 to $23 saved instantly. And where Apple spends roughly $100 to $120 per iPhone on global marketing and influencer campaigns, Musk spends almost nothing. His personal following, nearly 200 million across platforms, acts as Tesla's unpaid advertising engine. Analysts estimate that this viral exposure has already reduced Tesla's per-product marketing cost to under $3. When all these cost optimizations are added up, $26 saved from chips, $4 from batteries, $13 from automation, $20 from distribution, and $100 plus from marketing. The math lands at roughly $110 total production cost per unit. That leaves Tesla with a small but healthy margin, even at a $157 retail price. How is Tesla building the first smart machine in your pocket? Every major leak about the 2026 Tesla Pi phone points to one conclusion. This isn't just another gadget trying to outshine the iPhone. It's a convergence of Tesla's 3 strongest technologies: Starlink, Dojo AI, and aluminum-ion energy systems. The result looks less like a phone and more like a handheld Tesla, both in hardware philosophy and computational power. Starting with the display, Tesla reportedly chose a 6.1-inch FHD plus OLED panel supplied by BOE, running at 120 Hz adaptive refresh rate and pushing 2,000 nits of peak brightness. To put that in perspective, that's 33% brighter than the iPhone 15 Pro Max, and just slightly below the 2,300 nits found on Samsung's Galaxy S24 Ultra. The display supports HDR10+, 10-bit color, and a touch latency under 5 milliseconds, optimized for Tesla's Neuralink gesture prototype, proving the hardware isn't designed just for scrolling, but for direct human-AI interaction. Under the hood, the Pi phone is said to run on Tesla's Dojo Lite neural processor, a 5-nanometer 12-core AI architecture capable of 68 trillion operations per second, tops. That's nearly 2.3 times faster than Qualcomm's Snapdragon 8 Gen 3, 30 tops, and 1.8 times faster than Apple's A17 Pro in AI throughput. Built from the same base as Tesla's Dojo D1 chip, it reportedly consumes 20% less power per watt while maintaining sustained performance without thermal throttling, key for AI workloads and real-time satellite connectivity. Power comes from a 4,200 mAh aluminum-ion battery, equivalent to a 5,500 mAh lithium cell in usable energy due to its 1.7 times higher energy density. It can fully recharge in just 9 minutes using 65-watt GaN fast charging, and more impressively, maintains 98% capacity after 10,000 charge cycles. That means a Tesla Pi phone battery could last a decade of daily charging, compared to roughly 2.5 years for the average smartphone today. But what truly sets this phone apart is connectivity. It's the first reported consumer device to feature built-in Starlink direct access, allowing users to connect directly to low Earth orbit satellites with speeds around 50 to 120 megabits per second downlink and latency under 30 milliseconds, without a SIM card, carrier contract, or local tower. Tesla is also testing dual-frequency GPS, L1 plus L5, paired with Tesla Vision navigation, letting the phone function as a precision-grade tracker or off-grid navigator. The camera system reflects Tesla's deep experience in computer vision. The main sensor reportedly hits 108 megapixels, paired with a 50 megapixels ultra-wide and 32 megapixels front camera, all running on Tesla Vision AI image processing. Using the same neural algorithms that power autopilot, the system predicts motion and light behavior in real time, reducing blur and overexposure by up to 40% compared to standard AI ISPs. In materials and design, Tesla once again leans on its vehicle DNA. The chassis uses aerospace-grade aluminum composite, rated at 40% higher torsional rigidity than stainless steel, while the back panel is built from recycled Model 2 battery casings, a symbolic nod to Tesla's closed-loop sustainability model. Despite that, early engineering units reportedly weigh under 190 grams, thanks to internal structural optimization borrowed from SpaceX-grade alloys. Software-wise, the iPhone runs Tesla OS, a Linux-based system optimized for low-latency neural computing. It integrates seamlessly with the X app, Starlink Cloud, and Neuralink Sync. Tesla iPhone could mark one of the boldest crossovers in tech history, where automotive engineering, AI, and space connectivity merge into a single $157 device. Whether it truly threatens Apple's dominance or not, one thing's certain: the rules of the smartphone game are about to change. What do you think? Would you actually buy a Tesla phone if it connects directly to Starlink? Do you believe Apple can defend its ecosystem against this kind of disruption? If you enjoyed this breakdown, don't forget to like this video, subscribe, and turn on the bell so you won't miss our next deep dive into Tesla's most shocking upcoming tech.